All right, hello integrated 2. I want to talk to you today about graphing quadratics in standard form. We're going to do part 4, and then I'm going to do a part 5 where I actually do examples. So this is more of an introductory. Today we're going to change A. In your last lessons, we did A was 1 and negative 1. And that's what I said would be kind of for our Monday through Wednesday this week. So this is the last piece of graphing quadratics in standard form. Next week I'm going to give you graphing quadratics in vertex form. And we'll see that's actually going to be a little bit faster. But what I wanted you to do today is look at this particular example that I have right here. What I did is I set up y equals x squared, y equals 2x squared, and y equals 3. Okay? And so here is when a equals 1, when a equals 2, and a equals 3. And remember, what we're going off of is y equals ax squared plus bx plus c. So of course in these examples, b and c are 0, so they don't exist. And that's why you see the vertex for every single one of these problems at 0, 0. Okay, when we start putting stuff on the end, when we add in other terms, that's when our parabola starts shifting, moving, and flipping. Over here, a equals negative 1. A equals negative 2, and A equals negative 3, okay? So what we can pretend I did, we'll look at y equals 2x squared. What we can pretend I did is I substituted in 1, and I got 1 squared is 1, 2 times 1 is 2, and I substituted in 2, so you have to do exponents first, so 2 squared is 4, 2 times 4 is 8. And we'll pretend that I plugged in negative 1 and negative 2 and got the same values. Or remember, parabolas have symmetry. So we are basically here, here, and here. Now, the other day I was making this motion going, okay, we go up 3, and then, we go up 1, and then we go up 3. Notice here the pattern, when A is 2, we go up 2, okay, and then we go up 6. So we're going to get this steeper parabola, which you can kind of see behind me right here. So if you look at how I wrote this here, I wrote like 13 for up 1, up 3, and we do the same thing here. 26 is up 2, up 6, and 39 is up 3, up 9. So whenever I give you a problem, if you do not want to plug in and make the table, if you know your A value and know where you are, you simply add to the numbers. Now notice what happens here. When A is negative 1, we know our parabola is going down. So it's not up 1 and 3, it's down 1, and it's subtract 3. So subtract 1, subtract 3. Subtract 2, subtract 6. Subtract 3, and subtract negative 9. Now, that is a whole lot faster knowing these keys here than actually plugging in and doing order of operation, especially when the problem gets longer. Okay? And then what I wanted you to do is I wanted to make a graph of all 6 of these problems on one graph. Okay? And so what you'll notice here is blue is my x squared. Notice that 2x squared multiplying by 2 is going to make those y values go up faster. And then multiplying by 3 is going to make those go even faster. When y equals negative x squared, it's a reflection over the x-axis. So you can see the blues. Y equals negative 2x squared, then y equals negative 3x squared. So whenever a is negative, we're down, and whether a is positive, we go up. And what I would like you to do is You can take down all this information. You probably need it or snap a shot of it for your notes. But I would like you to I asked you the other day to download the Desmos graphing calculator. So I would actually, if you haven't done it, I would like you to do it. And you can punch in all 6 of these at the same time. So I would like you to get a visual for yourself. Okay? And then you're supposed to be checking your other assignments with it. And it's really cool because when you type in the first term, when you're doing the other problems, your parabola will appear right away. And as you put in your B, X value, you put in your C, it shifts to where it needs to be. And so remember, you're using the decimal calculator to get your answers to the problem. Okay, the plan in part 5 then is I have 3 examples to show you today. So once again, you can freeze time, take a picture of it, take it down for yourself so when you're doing the problems. But we're going to use this today to do our 3 examples. Okay? So that's the end of part 4, just a short little piece for you, and I'm going to get to part 5 here in just a second. All right? See you soon.